Hello everyone. Here we discussed maximum power transfer theorem. The maximum power transfer theorem discussion is different for DC and AC networks. Here we discussed for DC network. For a DC network, it states that maximum power is delivered to a load when the load resistance equal to the source resistance. It can be analyzed by a simple Thevenin's network. Here, a two-terminal linear active bilateral network analyzed by a simple Thevenin's equivalent at terminal AB, which is connected by a variable load RL. So here we will discuss the power transfer to this variable load will be maximum at what condition. Here we assume our load current is I, which can be calculated by Thevenin's equivalent, that is VTh divided by RTh plus RL. Now if you want to calculate our load power, that is PL, it can be calculated by I square into RL. This I is VTh divided by RTh plus RL whole square into RL. Now here we calculate the condition for the maximum power transfer to the load by source voltage VTh. So for this calculation we will differentiate this load power with respect to RL to maintain the maximum condition. So this dPL divided by dRL will be 0. It will provide a condition for maximum power transfer. Let's see. As RL is the variable load resistance, so differentiate this power with respect to load resistance RL. So VTh square is common constant, so this differentiation of d by dRL, RL upon RTh plus RL whole square. So differentiation of V by U is defined as U differentiation of V minus V differentiation of U divided by U square. According to this is RTh plus RL whole power 4. This RTh plus RL whole square into differentiation of RL with respect to RL is 1 minus RL into differentiation of this part RTh plus RL whole square with respect to RL. So this is our equation. So here we put this value is equals to 0. That means this dPL divided by dRL is equals to 0. From this condition we get the value, that is RTh is equals to RL. This is our condition when the load resistance is equal to Thevenin's equivalent resistance, then the maximum power will be transferred. Let's analyze the value of maximum power for the condition RTh is equals to RL. Our load power is I square into RL, that is VTh square divided by RTh plus RL whole square into RL. Put the condition, that is RTh is equals to RL. For the condition RTh is equals to RL, our maximum power calculated as VTh square divided by 4RL. In some cases, this maximum power calculated for the circuit design, but it affects the efficiency of the circuit. Now let's analyze the efficiency if we transfer maximum power to the load. Efficiency of any network can be defined as output power divided by input power. For the output power, our load resistance RL, this output power is maximum for maximum power transfer, that is VTh square divided by 4RL. For input power, our source voltage is VTh and our input current is I. So this input power is defined as VTh into I, and this I, you can say this is VTH divided by RTH plus RL. Here we sustain our maximum power condition, so we put the value that is RTH is equals to RL and calculate our input power. So our input power will be calculated as VTH square divided by 2RL. Now calculate our percentage efficiency. This efficiency is output power divided by input power. This output power is VTH square divided by 4RL. Input power is VTH square divided by 2RL. So it will be 1 by 2 into 100, means its efficiency is 50%. So the power transfer to the load will be maximum, but the net efficiency of this particular network will be 50%. It is the limitation of this theorem, and the applications and advantages will be discussed in the coming topic. Thank you for watching the concept. Please like and subscribe my channel.